From the industrial gauntlet of hexane baths and centrifuges to this quiet kitchen counter, the journey ends here.
These aren't just any soybeans lounging in Midwest soil. They're future vegetable oil with a 120-day photosynthesis appointment to keep. Each tiny soybean seed gets planted exactly 2 inches deep by GPS-guided precision equipment. Because apparently even seeds need coordinates these days. Spring warming triggers germination when soil hits 60 degrees Fahrenheit. And those seeds crack open faster than you can say sustainable agriculture. Pale green shoots push through dark, loamy earth seeking sunlight, beginning their transformation into protein-packed legumes that'll feed half the planet somehow. Soybean plants develop nitrogen-fixing root nodules that pull nutrients from thin air, making them the overachievers of the crop rotation world naturally. Trifoliate leaves unfold in perfect mathematical patterns, turning vast fields into emerald green carpets that stretch clear to the horizon line completely. White and purple flowers bloom across acres during early summer, attracting pollinators while quietly forming fuzzy green pods full of future possibilities awaiting. Those fuzzy pods swell with developing soybeans through June and July, packing protein and oil into each bean like tiny biological storage units. August heat pushes oil content higher inside each bean, creating the 18 to 20% oil concentration that makes extraction worthwhile economically speaking. As autumn approaches, leaves turn yellow then brown, signaling that photosynthesis party is officially over and harvest season is coming soon enough. Brown pods dry and rattle in September winds, making that distinctive sound farmers listen for to know their crop is finally ready today. Combine harvesters roll into fields like mechanical dinosaurs, their headers stretching 20 to 30 feet wide to swallow entire rows efficiently. The combine's sharp-cutting blade slices dried soybean plants at ground level. Because subtlety isn't really part of industrial agriculture's vocabulary here, plant material feeds into the threshing drum, spinning hundreds of rotations per minute, violently separating precious beans from worthless stems and pods. Golden soybeans pour through internal screens, while chaff and plant debris get blown out the back, creating dust clouds visible from miles away. Harvested soybeans collect in the combine's tank, accumulating until 200 bushels. Fill it completely. Then it's time to unload already. An auger extends like a mechanical elephant trunk, transferring soybeans into waiting grain carts with satisfying rattling sounds that signal productivity happening. Semi-trucks haul harvested soybeans to processing facilities, beginning their journey from muddy field to your kitchen cabinet in mere days. Surprisingly enough, at the industrial facility, trucks dump thousands of pounds into receiving pits, where soybeans cascade like golden waterfalls through underground conveyor systems. Vibrating screens shake incoming soybeans violently, removing stems, leaves, and pods that somehow survived the combine's aggressive threshing process back there. Powerful magnets pass over moving soybeans, extracting metal fragments like nails and wire bits that could damage expensive machinery downstream catastrophically. Air classification systems blow dust and chaff away using precisely calibrated wind speeds, because even microscopic impurities matter in oil production quality. Clean soybeans enter massive roller mills that crack each bean into 4 to 8 pieces, exposing cream-colored interiors for the first time. The cracking process separates brown seed coats from pale kernels, like opening thousands of tiny packages simultaneously at ridiculous industrial speeds constantly. Asperters use air currents to float lightweight hull fragments away from heavier kernel pieces, achieving 95% hull removal with pure physics. Separated hulls get collected for animal feed production, because nothing goes to waste in modern food manufacturing except maybe time and patience. Cracked soybean kernels enter steam-heated drums that warm them to 160 degrees Fahrenheit, making them pliable for the flaking stage. Steam injection adjusts moisture content to exactly 11%, because apparently soybeans are particular about their hydration levels before getting completely flattened. Hot kernels feed between massive steel rollers, applying tons of pressure per square inch, transforming chunky pieces into paper-thin translucent flakes instantly. These delicate flakes emerge only a 1/4 millimeter thick, looking fragile, but actually maximizing surface area for oil extraction chemistry to work. Thin soybean flakes enter sealed extraction chambers, where commercial hexane solvent waits, ready to dissolve oil like chemistry class finally getting interesting. Hexane sprays over flakes in countercurrent flow, meaning fresh solvent meets already extracted material first, for maximum efficiency and minimum waste, obviously. The solvent dissolves oil from flake surfaces over 60 to 90 minutes, creating an amber mixture called micella, that's 30% oil. Extracted flakes retain only 0.5% oil after this chemical bath, making solvent extraction far superior to mechanical pressing methods comparatively. Meanwhile, that oil hexane mixture drains away into collection tanks, looking like pale amber liquid gold that still needs considerable processing before consumption. Spent soybean flakes, still soaked with hexane, enter the dissolventizer toaster, a multi-deck, steam-heated tower that sounds more complicated than it is. Steam heating drives hexane vapors out of wet flakes at 220 degrees, recovering solvent for reuse while creating soybean meal simultaneously. Captured hexane vapors get condensed back to liquid form and recycled. Because hexane costs money and nobody likes explaining solvent losses to accountants. Dried soybean meal exits containing 48% protein, destined for livestock feed, where it helps grow tomorrow's bacon and chicken nuggets efficiently. Back to that amber micella mixture. It enters the first evaporator, where vacuum and heat separate oil from hexane systematically through physics. 3 evaporation stages progressively remove hexane at increasing temperatures, going from 150 to 180 to 2 to 10 degrees Fahrenheit, methodically climbing. Each stage boils off more hexane until only crude soybean oil remains, still containing traces of solvent that require final stripping treatment. A stripping column injects steam through crude oil, removing that last 50 parts per million hexane like the perfectionist final touch it is. Recovered hexane gets condensed and returned to extraction, completing a closed-loop system that recovers 90% of solvent for environmental and economic reasons. Crude soybean oil flows amber and thick into refining section, containing unwanted phospholipids, free fatty acids, pigments, and odors that must go. Hot water mixes vigorously with crude oil in the degumming tank, hydrating phospholipid gums until they become insoluble and heavy enough to separate. High-speed centrifuges spin at thousands of rotations per minute, using centrifugal force to separate dense gum layer from lighter oil phase completely. Removed gums can become lecithin for food products, so even refining waste becomes somebody else's ingredient, which feels oddly philosophical about recycling. Degummed oil enters neutralization reactors, where sodium hydroxide solution neutralizes free fatty acids, creating soap stock through basic chemistry you probably remember vaguely. Caustic soda and fatty acids react enthusiastically, forming dark brown soap that settles to tank bottoms, while cleaner oil floats victoriously above. Another centrifuge spin separates soap stock from neutralized oil, removing acidic compounds that cause rancidity and off flavors in finished products eventually. Hot water washes remove traces of soap from oil, creating temporary milky emulsions that clear after final centrifugation brings back golden clarity. Neutralized oil heats to 230 degrees under vacuum, while powdery activated bleaching clay gets added. Looking like weird science experiment ingredients, bleaching earth absorbs color pigments, trace metals, and oxidation products during 20 minutes of agitation that transforms everything it touches remarkably. Deep golden oil gradually lightens to pale straw yellow as chlorophyll and carotenoid pigments stick to clay particles, being removed methodically here. Filter presses remove spent bleaching clay loaded with impurities, leaving behind cleaner oil that's almost ready for grocery store shelves, but not quite. The final boss battle happens in deodorizer towers, where oil heats to 470 degrees under extreme vacuum conditions that seem excessive. Steam bubbles through superheated oil, stripping away volatile compounds that cause undesirable flavors and odors nobody wants in their cooking oil. Free fatty acids, aldehydes, and ketones evaporate away during 30 to 90 minutes of deodorization, leaving behind completely neutral tasting oil finally. High vacuum prevents oxidation at these extreme temperatures, because creating fresh oil just to ruin it immediately would be counterproductive and expensive. Deodorized oil cools rapidly through heat exchangers, dropping from 470 to room temperature faster than you can say polyunsaturated fatty acids correctly. Crystal clear, refined soybean oil flows into storage tanks, blanketed with nitrogen gas, protecting against oxidation until packaging day arrives at last. Quality control technicians test peroxide values, color measurements, and flavor profiles, ensuring every batch meets strict specifications before going anywhere else. Automated filling machines dispense precise amounts into plastic bottles at speeds approaching 100 bottles per minute, making human packaging seem quaint. Blow molding machines create bottles from plastic pellets seconds before filling. Because why store empty bottles when you can make them on demand? Bright yellow vegetable oil labels apply automatically as bottles whiz past, transforming anonymous clear liquid into recognizable supermarket products instantly here. Capping machines twist lids tight with calibrated torque, ensuring leak-proof seals that survive shipping, stocking, and shopping cart collisions remarkably well. Filled bottles accumulate on conveyors, moving toward case packing stations, where robotic arms arrange them into cardboard boxes with mechanical precision always. Palletizing robots stack cases 40 high, creating shrink-wrapped cubes that maximize warehouse space while minimizing forklift trips around the facility constantly. Climate-controlled warehouses maintain ideal storage conditions, protecting refined oil from light, heat, and oxygen that accelerate rancidity over time. Unfortunately, from a single soybean seed to bottled cooking oil takes approximately 5 months total, though the industrial processing happens in just days. Each gallon of soybean oil required roughly 60 pounds of soybeans to produce, making agriculture the original multiplication miracle before spreadsheets existed. The leftover soybean meal, after extraction, feeds livestock worldwide, creating a perfect agricultural circle where nothing truly gets wasted remarkably enough. Industrial soybean oil production achieves 99% oil extraction efficiency, leaving almost nothing behind except protein-rich meal and industrial pride basically. Temperature control matters everywhere in this process, from field harvest timing to deodorizer precision, making thermometers surprisingly important, kitchen equipment enablers. Hexane solvent gets recycled through extraction cycles hundreds of times before replacement, proving that even chemical solvents deserve second chances and thirds. Modern processing facilities operate continuously 24 hours daily, transforming train car loads of soybeans into tanker trucks of oil without stopping ever. Food safety protocols require constant monitoring, testing, and documentation, because nobody wants to explain contaminated cooking oil to regulatory agencies or customers. Steam provides heat throughout the facility, from conditioning to desolventizing to deodorizing, making the humble steam boiler secretly essential to everything. Vacuum systems create low-pressure environments for evaporation and deodorization, because sometimes you need less atmosphere to make better food products mysteriously. Centrifugal force separates liquids of different densities repeatedly throughout refining, spinning materials until physics sorts everything into proper layers automatically somehow. Each processing stage removes specific unwanted compounds, building toward that perfectly neutral cooking oil that won't interfere with your recipe's flavors. Refined soybean oil contains 0 grams trans fats unless partially hydrogenated, which most producers avoid nowadays for obvious health and marketing reasons. The oil's light color and neutral flavor make it America's default cooking oil, hiding anonymously in kitchens everywhere under generic vegetable names. High smoke point around 450 degrees makes soybean oil perfect for frying, sautéing, and high heat cooking that olive oil simply can't handle. Polyunsaturated fats constitute 58% of soybean oil, including omega-3 and omega-6 fatty acids that nutritionists debate endlessly about ratios. Industrial refining removes natural vitamin E somewhat, though enough remains to provide antioxidant benefits and slow rancidity during storage time. Fortunately, soybean oil production ranks among the world's largest agricultural industries, processing over 57 million metric tons annually across all continents combined: United States, China, Argentina, and Brazil dominate global production, growing and processing soybeans that eventually reach dinner tables everywhere, somehow reliably. From farm to factory to grocery store takes roughly 2 weeks in modern supply chains, making fresh oil surprisingly fresh despite complex processing. Unopened bottles maintain quality for 12 to 24 months, though oxidation accelerates once opened and exposed to air and light repeatedly. The same soybean oil appears in salad dressings, mayonnaise, margarine, baked goods, and countless processed foods you consume without realizing it. Industrial buyers purchase soybean oil in tanker trucks and rail cars, measuring it by the ton rather than the tablespoon like normal people do. Soybean oil even powers biodiesel engines after additional processing, proving that today's cooking oil could become tomorrow's renewable fuel source. Alternatively speaking, every soybean begins its life as a tiny seed containing the genetic blueprint for producing oil. Humans will eventually cook French fries in, from photosynthesis to solvent extraction to deodorization, represents a journey through biology, chemistry, and engineering that most people never consider once. This golden liquid, sitting anonymously in plastic bottles, traveled through more processing stages than most Instagram posts. Get filters applied honestly. Industrial efficiency transforms humble legumes into billions of gallons annually, feeding the world's appetite for fried foods and salad dressings simultaneously, always. Next time you grab that bottle of vegetable oil, remember, it survived combines, hexane baths, and centrifuges to reach your shopping cart. From Midwest soil to kitchen cabinet, soybean oil production combines agriculture, chemistry, and automation into one remarkably efficient, modern food system.